Hey there, awesome physics students. Let's talk about the difference between vectors and scalars. So what is a scalar? Scalar is just a fancy word for a number. It's just a number. It doesn't have any sort of direction. The key characteristic or difference here is it doesn't have any direction information. A vector is a magnitude and a direction. And what do I mean by magnitude? Well, it's just like a length or an amount. Some examples of numbers, scalars, that you've seen before are things like mass. That's a good example. Time. Anything that can be derived by differences in two scalars, like a time interval, that would be also a scalar. Some non-physics examples are money. So if you have $5 in your pocket, that's going to be a scalar. If you owe someone $5, that's, you're in debt. So an important note here is that scalars can be negative. That's allowed. Okay, they still don't have any direction, so that's the difference there. One more important physics example is energy. Energy is a scalar. It's just a number, just an amount. Vectors, on the other hand, have a magnitude and direction. Some examples of that would be displacement. And we usually, to make it clear that we mean something to be a vector, is that we usually write the symbol with a little arrow on top. An alternative that some textbooks will use is they will make it bold. I can't easily make it bold here, so I'm going to use the arrow notation. Another common one that we'll talk about very soon is velocity. And that's just, we usually denote that with a little v. Another one that we're going to talk about soon is force. And with this, the magnitude, I want to note one more thing here. The magnitude of the vector is always positive. Okay. This is just the length. And so we often denote vectors like force, for example, with an arrow, and then the length represents the magnitude, and then the direction, of course, is the direction of the arrow. Okay, so that's the main distinction between vectors and scalars.